Hey everyone, welcome back to another crash course video from Team Ink and Metal. Today we'll be talking about what RoadRunner is and what it is used for in FTC. So what is RoadRunner? RoadRunner is a motion planning library specially developed for FTC. It is primarily useful for the autonomous period. It controls velocity and acceleration while following complex and accurate paths. There are some key terms to know for using RoadRunner. The first is localization, which is the ability for the robot to know its location. A common method for doing this is odometry. Odometry is a usage of sensors to determine the robot's position. Next is motion profile. This is the graph of a behavior which must be followed to reach a certain stage. It maps movement to reach a certain point. In RoadRunner, it shows the velocity of the robot to reach a certain point. The graph can be modified by defining max velocity, acceleration, etc. There is also open and closed loop control. Open loops are where you have an existing mathematical model and you guess the input to enter. They are not always accurate. A value is sent, but you can't always determine whether it actually works. But if you wanted to work more accurately, then closed loops would be a better option. Closed loops give feedback directly from the encoder, so they can be modified to suit your needs. Vector 2D gives a 2D vector, which is an xy coordinate. Pose 2D gives an xy coordinate and also a heading. Heading is a direction at which the robot is going. Spline movement is curved and smooth, and it can change the heading without making a point turn. Some essential things that make up RoadRunner are paths and trajectories. Paths are routes based on defined waypoints. For example, they can be lines, splines, etc. Trajectories are paths with motion profiling. To build a trajectory, there are some functions that you can use. The forward function moves the robot forward, the back function moves the robot backward, the strafe left function moves the robot left, and the strafe right function moves the robot right. The strafe 2, line 2, and line 2 constant heading functions all have the same result, which is to move the robot to the specified coordinates while keeping the same heading. The line to linear heading function moves the robot to specified coordinates linearly while changing its heading from the start to end position. The line to spline heading function moves the robot to the specified coordinates in a spline movement while changing its heading from the start to end position. The spline 2 function moves the robot to the specified coordinates in a spline movement while following a tangent heading. The spline 2 constant heading function moves the robot to the specified coordinates in a spline movement with constant heading. Adding the end tangent parameter can affect the shape of the spline. The spline 2 linear heading function moves the robot to the specified coordinates in a spline movement and linearly interpolates the heading. And finally, the spline to spline heading moves the robot to the specified coordinates in a spline movement and spline interpolates the heading. Thank you for watching.